Welcome to this course on software estimation, wherein we will walk you through the various aspects of software estimation as observed and followed by the practitioners in the industry. We will look at various elements involved in software estimation. We will also have a look at some of the commonly used methods, tools or techniques for software estimation and covering one of the model in detail. Following is the course agenda. Why software estimation is needed, why software estimation needs to be reasonably accurate, who are the people involved in software estimation, what are the approaches being followed for software estimation, and what are the sizes or sizing matrices being used or followed in the case of software estimation. Some of the commonly used methods, tools or techniques for software estimation are listed. The first is a task or process complexity based estimation method, wherein we estimate based on the tasks involved for the functionality. Then we have wideband Delphi estimation method, wherein we do a brainstorming of the various experts involved to arrive at an estimation. Then you have a work breakdown structure, which is commonly used in conjunction with Microsoft project. Then we have program evaluation and review technique PERT, wherein we follow the 3-point estimates. Then you have function point estimates, wherein the requirements of the system or the application is collected in the form of a function points, which is technology agnostic. We can estimate in terms of function points and then go ahead and follow any particular technology, whether it could be Java or whether it could be Microsoft. Similar is the case for use case point as well, UCP. Here again the requirements are collected or the size is collected in the form of use case points, and then again we can follow any technology, whether it could be Java J2E, Microsoft or other technologies. Then you have the COCOMO model, which is an algorithm based software estimation model being used with parameters which are derived from this historical project data and current as well as future project characteristic. We will also cover function point model in details, and also we look at the correlation between effort, schedule and cost estimation, because at the end of the day, once you have the efforts collated, you need to translate into a schedule so that one gets a fair idea when we can look at that particular application or the system being talked about going live. Also the cost involved in getting the project to a live stage. We look at project tracking, wherein we will look at the correlation, how the estimates are compared versus actual. Then some good practices to follow for estimation, some common mistakes to avoid based on the experience of the people in the industry. This is a Dilbert cartoon. So some of you who are aware, this is Dilbert and his manager, wherein people take normal project management and other aspects in a lighter vein. So you can see the manager comes in and asks Dilbert, he needs an estimate for the project. Now Dilbert has not even started collecting the user requirements, and still his manager is insisting that he needs at least a ballpark or a guess estimate. Now Dilbert is worried that this will be kind of held up against him, but the manager insists, and so Dilbert quotes, okay, the particular project will cost $10 million. Now on the face of it, the manager thinks it's too high, and so Dilbert is trying to tell him, if you know it's already too high, why are you asking him? Now this particular cartoon is actually trying to portray the thing in a lighter mood. However, when we see in industry, there are a lot of people who actually do project estimation like this, wherein there is no basis for project estimation. So people look at requirements or the people look at just the initial feasibility note and they decide, okay, so what is the cost going to be or what is the effort going to be. Now while we do understand that at the feasibility stage the requirements are not collected to a details, or there may be points which are not very clear, so we need to make assumptions. However, we still need to follow some sort of a estimation method so we know against what we are benchmarking later when the project is been executed. This is what we are covering here in the subsequent slides. Now a project would be considered successful only when agreed functionalities are delivered on time, as per agreed cost and with the required quality. This is a universally accepted point that agreed functionality needs to be delivered on time, as per agreed cost and with required quality to the client. Now as per a survey conducted and survey listed in the chaos report, 24% of the projects surveyed have been identified as failed, which means they didn't meet the requirements of the project or the objectives of the project. Now 44% of the projects were categorized as challenged. So what that means is these projects are definitely not successful. So if you see, almost 2/3 of the projects not been successful. So either they have completely failed or they are in a very bad state. This illustrates the importance of project estimation and planning. Now, as per studies done, one of the major causes of project failure was attributed to lack of proper planning and estimation of resources, schedule and cost. Sound estimation model which is tuned to the organization experience is the key to effective project planning, execution, monitoring and control. Now we may be wondering why project planning, execution, monitoring and control is been talked about when we were discussing about software estimation. The reason being, software estimation is the basis on which a project is being granted by a client to a vendor, and once the project is formally started, people need to track back and see how we are performing as compared to the estimates provided, and so then that relates your project planning, execution, monitoring and control to the earlier estimates provided. Now we can see the triangle, and there's a person who is confused as to what he should consider first, whether he should look at scope, schedule or resources. Now this is called the triple constraint of scope, schedule and resources, which ultimately is cost, with quality as an additional factor of consideration. So you can't look at only one item in isolation. So you can't look at only scope so that you try to satisfy the customer by giving in all his change requests or whatever changes he keeps asking for the requirements, or you can't keep going from say June to July to December and keep extending the schedule, or you can't keep putting infinite number of resources on the project. So ultimately you need to tie all the three, the scope, schedule and the resources together, so that, as we have seen in earlier slide, the agreed functionalities are delivered to the client on time, as per the agreed cost and with proper quality. So what is the definition of estimation? So wiki definition, as you can see, what it says is, estimation is the process of finding an estimate or approximation which is a value that is usable for some purpose, even if input data may be incomplete, uncertain or unstable. So to simplify this, what they are trying to say, or what the definition is trying to say, is estimation or estimates is not an absolute number, rather it's a range or an approximation. So when we say how much time will it take for you to come from your home to office, so one could say 1 hour, one could say 50 minutes, one could say 1 hour 15 minutes. So it's basically a range within which one can predict that a person will reach from his home to office. So similarly, in executing a project or in terms of delivering or building an application or a system, which is the end goal of a software estimation, one needs a predictability saying that what is the approximate cost in which this particular project will be delivered and in what are the timelines. So input data may be incomplete, uncertain, unstable. So essentially what this definition is trying to say, even if some of the parameters are not complete or not known at this point, you make assumption and looking at the other available data points come out as an approximation method that this is the estimate which holds true with the available data points, and with some of these unknowns been handled with the help of assumptions.